cancel. The next one is using functional connectivity to predict working memory performance in human Connectome project presented by Richier, PhD student in the Heller lab at the University of Illinois. And I think that we will have a great talk by Gray. Let's Gray to share his screen and start. Thank you.
All right, hello everybody. My name is Corey. I'm here to present a project that was undertaken by me and some group members of mine actually we participated in the Neuromatch Academy earlier this summer, which was a great experience learning, building some skills in computational neuroscience. So all four of us, Ladan, Davide, Nora, and myself are graduate students at various universities in the United States, Canada, and Europe. So it was really cool getting to know and work with everybody. As part of that, we presented a project, or we worked on a project. So what I'm going to do is talk a little bit about that, our experiences from what we learned, and some implications for building models of predicting cognitive performance. So we'll get right into it. So a central goal of neuroscience is to make predictions or understand how patterns of neural activity relate to cognition and behavior. So one common way to utilize this is using fMRI, task-based fMRI, as well as resting state fMRI. A core component of many aspects of cognition is working memory, which is related to a lot of basic as well as clinical outcomes of central interest for my lab, as well as many others. Supervised machine learning is becoming more sort of like a growing method for predicting different outcomes based on aspects of neuroimaging. So things like age prediction, vision, different clinical and psychopathological traits as well. Machine learning has been used to predict working memory performance in EEG in terms of other neural measures, but we sought to use machine learning to try and predict working memory performance using data from the Human Connectome project. So like I mentioned before, all four of us met and worked in the Neuromatch Academy, and as part of our participation, we were provided a subset of the HCP data set with the Glasser parcellation. So we implemented a general linear model approach just to sort of see what would work best using ridge, lasso, and elastic net regression. So ridge regression works to reduce overfitting by shrinking the magnitude of model coefficients, whereas lasso will compress some coefficients to zero. Elastic net utilizes some combination of both of these procedures. So procedurally what we did is we built our models using Python and scikit-learn. We decomposed the Glasser parcellations, the connections to be predictors for a model. We used grid search CV to search for the most effective alpha values for our regularized regression models. And then we fit our ridge, lasso, and elastic net models with a 10-fold cross-validation. Specifically, what we were attempting to predict was predicting working memory accuracy from both the task and rest activity that were provided and seeing which was better. And what we found was maybe ridge regression worked a little bit better in terms of the R-squared value. While the root mean squared error seems promising, we may have had a little bit of a problem with overfitting due to the large number of predictors and not necessarily having a huge number of samples. So in terms of what we learned from this project, task activity was found to be a better predictor of working memory task performance, but only for ridge regression. Otherwise, the models seem to mostly perform the same. So a possible implication for this is that task and rest activity have been found to be pretty similar overall. So that might have some implications for building machine learning models of using resting state or task-based fMRI. Maybe in some cases they could be equivalent. Sort of, maybe it's hard to know necessarily from what we did. And I think another interesting point to be made is the brain linear? Is it, this is sort of like a hot topic of debate, but does it make sense to build linear models? Maybe for some cases it does, maybe for other cases it doesn't. And some other analyses that we did, we found that frontal parietal networks are found to be more predictive of working memory performance, which bolsters a lot of the literature. We use, and maybe it's some things that we could expand upon in the future. So we use functional connectivity as predictors. So that really compresses a lot of the temporal dynamics. Maybe that's where we lost out on some of our predictive capacity, as well as smoothing over the block types of the working memory task in the Human Connectome project. Actually has a lot of subcomponents that we didn't necessarily investigate. And then, and also establishing accuracy. So we are basically predicting like the continuous score of accuracy. Is it necessarily the most useful thing to predict? Maybe it's more useful to try and predict like how a person will perform on an individual trial or something like that. And then lastly, probably our biggest methodological thing that we had to tackle next time is our problem with dimensionality. So we had way more features than subjects, and that probably led to some problems in building our model. All right. Those are my references. Otherwise, thanks for listening. I guess we have some time for questions, right? For the interactive talks.
Thank you for your talk, and let's send the question in the question button at the Zoom. We will ask them from the lecturer. And also, there's one question that I have, that you found that the performance by frontal parietal network is predicted better. How about the other network or connection? Is there any other network that predict the performance of subject in the task-based data?
I don't think so. I actually didn't. I'm probably not the best person to answer that question from our group. Some of the other group. I'd like to say that our group all contributed to this equally. So some of us were more involved in some processes than others. So I think, and from my understanding, was that was the network that was found to be the most predictive. But I will let, if there are other group members here, they can maybe speak to that.
Okay, there's another question by Hadi Mutamedi. What would be the feature matrix for this HCP dataset?
Feature metrics?
Yeah, feature matrix for this HCP dataset.
Could you maybe elaborate on that?
Can you ask from Hadi if he wanted to ask the question himself?
Oh, what do we train on?
Forouzan, can you bring him?
Yeah, so we were training on the parcellations of the, oh, I guess they're coming in. So if they want to ask their question.
Can you unmute your microphone, Hadi?
Hello, can you hear me?
Yeah.
Hello, everyone. Great talk, thanks. So to elaborate on the question, my question was that, is this, so you did last regression and ridge regression, I think. So my question is, what exactly is the feature matrix? And so our output is, we want to predict the working memory. So we know the labels, that would be our outputs, right? But what are the inputs, the X which is put together in features, which we will regress our regressors to come up with the predictions and train our beta values? I don't know if I could be clear about that.
Yeah, sorry, it was clear. I think I just misheard last time. So that was the, we parcellate, uses the Glasser parcellation. That was what was provided for us in the data. And then we evaluated the functional connectivity matrix. And then we decomposed the matrix into the connections, each of the lower diagonal of the matrix. And then that was the features that we used to train on. Does that clarify?
Yeah, right. I get it. But how do we encode the time into this matrix, do we account for the time variation in the fMRI dataset? Because it's time series, right?
Yeah, so this is like where, this may not be the best approach, because what you in effect have to do is compress down a long time. So you're basically taking the average of that connection over the entire time series.
Oh, I see.
Yeah, so it's like in essence, the time variation, and this is, I guess I covered this a little bit fast, is sort of lost using that. So like using some way to evaluate dynamic functional connectivity, so like how the things fluctuate, some variance like would maybe probably be a lot better. But hopefully that clarifies. It's sort of like agnostic to time.
Yeah, thanks. It's clear now. Thank you.
If there are any other questions that we can ask for you, we have 4-minute time.
I think I will say that Ladan, one of our teammates, hi Ladan, she also worked on this project. She's saying that we tried other networks and the frontal parietal network was the best one. So thanks for jumping in there.